So make sure your pictures include your notes as well, the notes that you've taken in class, and then also the homework part. Okay, for your homework, you need to write down your steps, not just the final answer, unless the question is very easy. Okay, like 1 + 1, you can just write 2, right? No steps to show. So 2 things to show in your homework. Okay, so next part is the lessons. Okay, so I'm gonna share the screen. Okay, give me 1 second. Okay, so I'm going to change the screen now to the book. Okay, so you guys can take out the book 1. So you're all in grade 12 now, right? So the next question that I want to make sure is how many of you are taking grade 12 at school right now, in the current semester. Okay, so can you please raise your hand if you are taking grade 12 math in school right now? Okay, because sometimes they teach different order, right? So I need to know what orders your teacher is teaching so I can better fit your schedule. Okay, no, only one. Anyone else? Do I just leave it? Okay, I'm just checking the message now. Okay. Lily? Okay, Lily, you said what do you mean you just leave it after I add you using the code? What do you mean?
Do I just like click add and then everything's fine, right? I don't have
Yeah,
to do it.
you just add me in, and then later I'll figure out how to put you guys all in into the group. Okay, because first I need to get you guys onto my contacts, and then I can group them together. Okay. Yeah. Okay. And Jocelyn, I think I heard you, right? Your mic is it working now?
I don't know.
Oh yeah, it's working now. I can hear you now. Good. Okay. So Yosher is the only one taking the grade 12 now. Okay. So everyone is next year, right? Everyone else. Okay. So, right, I'm gonna lower your hands now. Okay. So Yosher, if you started the grade 12 now already, right? What's your first topic?
Transformations.
Okay. Yeah, but since you already covered it in summer, right? So far, so good. Any questions?
No.
Okay, so I'm gonna start with the functions anyway, okay?
Okay.
And then if in any time you have question from school, you just ask me, okay? During the break or after class, okay? All right. Yeah, so since it's only one student taking it, then it's good. We'll just follow our own schedule, okay? That way, I think it's best to cover everything in time, okay? We don't have to jump here and there. Okay, so that's the second thing, okay? And then, okay, first thing, WhatsApp, second thing, homework, right? Okay, and then the third thing, I think basically because this is a very big group, okay? So I will try my best to get you guys engaged by asking you questions, okay? So when I ask question, you turn your mic on, okay? And then we can communicate, right? And we'll be using the raising hand function a lot. And for the homework, or back to the homework. So when you hand in the homework, you will get it back the week after. And then for the first maybe 15, 20 minutes, okay, we'll go over any question you may have on the homework before you hand it in. Okay, so for example, assign the homework today, right? You will hand in next Saturday. But before you hand it in, I will make sure you finish all the questions, you try it out. Don't skip anything, right? If you have questions, you can ask me during the class, like at the beginning of next class, and then you complete that, and then you submit it, okay? So you don't skip, right? That's the only way you can learn everything. And then, so if you couldn't finish it, right? For some reason you couldn't finish it, you have to stay after class to complete that. Usually each week, the homework amount is about an hour to maximum, I think, an hour and 30 minutes, okay? So make sure you schedule, organize your time so you have a 1 hour slot, okay, for the homework, okay, of this class. Yeah, okay, so I think we can start, all right? Does anyone have questions so far? I think half of you have been with me before, okay? So you guys know how it goes. So on the first topic, okay, so if you're ready, okay, can you guys raise your hand? Okay, Jocelyn, do you know how to use the raising hand function? And Waylon? Yeah, okay, perfect. Okay. Oh, we can do clapping hands too. Is that clapping hands? Okay, yeah. Okay, so don't worry about lower the hands, okay? I will lower the hands for everyone, okay? You guys just worry about how to raise hands, okay? Or when to raise hands. So this grade 12 divided into 2 books, right? Book 1, I put all the major topics in book 1, okay? Because in this class, it doesn't matter that much because everyone is learning ahead of school, right? So these are the topics that are important. First one is a function transformation, okay? As you can see, trigonometry, there are 2 parts. In your textbook, it might show trigonometry, trigonometric function, okay? And then that's part 1. And then the other topic will be trigonometric equations, will be part 2, okay? So together, I just call them trigonometry. And then the last one is called the exponent and logarithm. So we probably won't cover all the topics in term 1, but I'm just putting here, okay? So in case anyone needs to do the jumping the topics, okay? Because some teacher, they teach exponent first, some teacher, they teach trig first, okay? So that's why I put it together. So after you finish this one, book 2 will be much easier, okay? Now, next part is the homework page, right? So homework page is just record the homework. Of course, it will also be on Google Classroom, okay? So don't worry about that if you didn't fill that out. And then the formula sheet, as we go through the class, we'll go back to here to fill this in, okay? You can see the left side is all about trig, okay? So trig is a very important topic. So we'll start with something easy, okay? Our first class is called the functions, okay? So before we dig in, let's look through what's inside here, okay? So first we'll review what function represents, okay? And then part B is if you have more than one function, we can do operations, okay? Operation includes adding, subtracting, multiply, divide, okay? And then how to graph them. After that, we have part C. Part C is called the composition function, okay? And then we have inverse function. And last part, square root of a function, okay? A, B, C, D, E, so 5 parts, okay? So each part will assign homework. So homework will be related to what you learn, okay? So if you think you have trouble with the homework, try to check your notes first, If still doesn't help, then you just ask on WhatsApp, okay? And I'll answer you as quickly as I can. Okay, so get your pencils out, okay? So we're gonna start now, right? First time you saw the word function, I believe it should be in grade 10. Okay, so I'm just pick randomly to ask you guys questions, okay? So definition of function. Given a relation between x and y or a set of order number x, y, if for something value of x exists some value of y. What do you think we should fill in there? Daniel? Daniel?
Oh yeah, is it for every value of x and then exist one value of y?
Oh, perfect. Very good. You remember your stuff. Okay. So for every means just one, right? So every single one value of x, it can only have one value. Exists. We'll add one more word. Okay. Exists only one. Okay. So the key word is only one, right? Only one. You cannot have two y values for each x. It's like calculator, right? For example, you type in 9, right? You type 9 into your calculator and then you press a function. Function is like different buttons, right? Some function has a square root, that's a function. Whatever that comes out, right? The answer will be, for this one will be 3, right? You cannot get two answers out of it. So this part is your input, right? Your input 9, that's your x. And then you have your output, and this will be y, right? So you get a pair of x and y, so 9 and 3. So you can put them together, 9, 3. So whenever you input an x, you get only one number out, then we call this a function. So this thing here is a function. Okay, so you can use calculator to understand what function means. Okay, so there are different functions. Some function they do square root, some function they do squares, right? And some function they do cube root, right? Different kinds of function. So then this relation, right? When we have this thing happening, we call it a function, and the notation is written like this, right? So this is not f times x, okay? Together it's one thing, f of x, right? F of x. So in the example we did, we'll say f, the function, we input the x value of 9, and it comes out a value of 3, right? If we use our function is square root here, okay? So the way to read this is we say f of 9 equals to 3. So this part is x. Okay, you guys can write this down. This part is the y. And the whole thing here, the green part is the y as well, right? Everything on the left is 3. So everything on the left is the y. And then we have these two words, okay? Domain and range. Domain is all the x values, all the x that you can sub in. Okay, so for example, the example we have, is there any numbers that we cannot put into the square root? Lily, what do you think? What kind of value you cannot input into square root?
4,
4, how come we cannot put 4 in?
5, 5.
5, how come?
Yeah.
When you type 5 into your calculator and square root it, will you get an answer out?
Yes.
Yes, then 5 is okay, right? As long as you can get an output, then it's fine, right? Is there a number you cannot get an output? We have someone raised their hand. Oh, Okay, Nicholas?
Negative numbers,
Yeah, like what?
-3, -7.
Yeah, very good. Okay, so if I try to put in a -3, you cannot square root a -3. Okay, because there's no number that times itself can give you negative. Okay, so anything that's negative is not possible. So for this example, our domain will be anything that's either 0 or higher. Okay, for the function we were just saying here, right? So let's write it on. Okay, we'll just put it on the top. Okay, so for the square root, okay, the function, the domain will be x is greater, right, bigger or equal to 0. And x is whatever that's inside. Okay, so that's just an example to explain what domain means. Domain is describing what kind of input you could use for that function. Okay, could be square root function, could be square function. They all have different domain. Okay, and then range, it depends on the domain, right? So range is all the corresponding y values. Okay, so if you know the domain, you can use it to find the range. So at the bottom, we have a couple different functions we're gonna try and then explain the domain range for these, okay? So because each function, we can make a pair, and a pair represent a point, right? Like 9, 3, it's a point. So you can graph it out, okay? So we're gonna try this out. Okay, anyone has questions so far? Okay, this should be a review for some of you, right? Okay, question 1, graph each function, then state its domain and range. So for the first function, okay, you have a square, right, on the x. Does anyone remember from grade 11, what kind of function do we call something with x squared? We have a name for this kind of function. Yeah, Daniel?
Quadratic.
Yeah, very good. Okay, let's write it down, quadratic. How about let's give them all names, okay? So quadratic function here, for B, does anyone remember the name for question B? Okay, Daniel again.
Radical.
Radical, okay. Radical function, okay. What about C? What would you call it? This time the x is in the denominator. You also learned this in grade 11 as well. Something that's written as a fraction, Daniel?
Rational.
Yeah, rational function, very good. Rational. Okay, last one, we have 2 bars. Okay, I don't know if you have seen this before. 2 bars around the x plus 3. What do we call this kind of function? Nicholas?
Absolute value.
Yes, very good. Okay, absolute value. If you don't know about these words, it's fine. Okay, as we go over each one, now I'll explain, okay, what it does. All right, so let's start with the first one, quadratic function. So make sure you copy these notes down, okay, as you need to take pictures of your notes later, okay? I'll be checking your notes. Okay, so for quadratic function, it looks like a U shape, okay, parabola. So the points we're gonna pick is symmetrical, okay? So we'll pick -2, -1, 0, 1, 2. So I'll let you guys fill out the table, okay? I'll do the first one in case you forgot how to do it. So to get the y, you put -2 into the x, right? So we can show the work, you can write it like this, right? F of -2 means your input is -2, right? So -2 squared minus 3. So you replace your x, right? Whatever you see there, you put it into the x part. Make sure you have brackets. And then you get an answer. The output will be Marcus, what's the output?
Sorry, what was that?
What's the answer for the first y?
Isn't it 1?
Yeah, it will be 1. Okay, very good. Right, so continue. Okay, so when you finish the whole table, please raise your hand. Okay, Sophie, do you have the answer for the second point, the second y?
Yep, it's -2.
-2, very good. Okay, so show the work as well. -1 squared minus 3, -2. And Jenny, what's the next point?
I got -3 for the y.
Very good. Okay. And then after that, it should be symmetrical, right? This is a parabola. So it'll be -2 again, and then 1. Okay, so we are gonna graph them on the grid. So -2, 1, our first point, -2 is x, 1 is the y, so it'll be here. -1, -2, right? 0, -3, 1, -2, right? So you've seen this graph before in grade 11. Okay, so the x value, right? When we talk about domain, it's the x value. What kind of x value can we put in, right? Can we use to calculate? Is there a limit? Is there a restriction to it? Evan, what do you think? Is there any restriction on you using the x values?
I'm not sure, but I think not.
I'm sorry, can you say that one more time?
I'm not sure.
Okay, is there any number that we cannot use to calculate? Yeah, Nicholas?
No,
There's nothing, right? I can
and
use
you can call me
decimal.
Nick.
Huh?
You can call me Nick. It's
Okay, yeah. Okay, so there's nothing, no restriction to it, right? I can use decimals, right? Usually you can check can we use decimal numbers? Can we use fraction number? Can we use positive numbers? Can we use zeros? Can we use negatives, right? Usually you just check these options. So if you can use anything to put it in and you are able to get an output, it's okay, right? So it looks like this one, I can square any number I like. I can use negative, I can use decimal. So this one will say it's all real numbers. Right? So we can say the domain is all real number. Another way to write this is you can write the R with a double line, okay? This represent all real numbers. Okay, and also you can see on the graph, right? The graph keeps on expanding to the left side, right? If I make it taller and taller, it goes to the left, goes to the right, right? It gets wider to the left side and right side and never stops, expands to both ends. So that also shows you is anything, okay? It can be any number you like. Now for the range, you need to look at the y values. Okay, so the best way to see the range is from the graph. All right, Eric, what do you think the range is?
Y is greater than -3.
Okay, would it touch -3?
I think so.
Okay, so what would you say then?
Oh, greater than equal to.
Yeah, okay, so it will be greater means higher or equal to -3. So you can see from the graph, you think about if it wants to go up, is there a limit? Right, it keeps on going up, there's no limit, right? Because y is going up and down, right? If it goes down, the lowest point it can get to is here, right? I'll use a different color, right? This is the lowest point. This is at y equal -3. So it starts from -3 and then going up. So that's why you get y greater or equal to -3. Okay, so domain and range could be different, right? Talking about different things. So usually range is better to get it from the graph, okay? From graph, okay, it will be easier. Okay, next function is called the radical function. Okay, so for radical function, since we mentioned that at the beginning, right? We said the domain is x greater or equal to 0, but that's not always true, okay? Because you need to think about what is inside the radical, under the radical. So the best way is to say whatever inside, you must make sure is greater or equal to 0. Okay, cannot be negative. So let's start with choosing the x values, right? Because this time under the radical. Okay, so Philip, what's under the radical?
X plus 4.
Yeah, x plus 4. Okay, so we want to make sure the x plus 4 is not negative. Okay, so we start with x plus 4 greater or equal to 0. You need to make sure you can keep that true, right? Otherwise, you won't get an answer out, right? So that's how we choose the point. So what kind of x values, if I put it in, will be greater and equal to 0? Selena?
What was the question?
I want to make sure inside the square root is positive or 0, right? So what kind of x value can do that?
Any positive number?
Okay, like what?
1.
1, yeah, 1 plus 4 is 5, right? 5 is still positive. Can we go any lower than 1? Anything lower?
Oh, yeah.
Like what?
-4.
-4. If I put -4 in, what do you get?
0.
You get 0. Can we go lower than -4?
No,
Because,
it'll be less than 0.
yeah, okay, it will make the inside negative. Okay, very good, Selena. All right, so the lowest point that we can use is -4. Okay, anything lower than -4 as x, it will make the inside negative. Okay, this part is the inside. Okay, so we'll start with -4 and then we'll slowly go up. Okay, -4, -3, -2, -1, and 0. Okay, so we're gonna use these numbers to get the outputs. Okay, so same thing like before. We start with f of -4. And then we put into the function that they gave us. So it will be square root -4, right? That's our input, plus 4. Okay, and Susan, what's the answer for this one?
0.
0, very good. Okay, square root of 0 is still 0. So we have our first point, -4, 0. Okay, so please continue to finish the table. Okay, once you finish the table, you can raise your hand. Okay, let's check some answers. Eric, can you tell us your next value for y?
I have square root of 1.
Which is
Let me check.
what number times itself will be 1?
1.
Yeah, so answer will be 1. Okay. Okay, next one. Jocelyn, you can type it out. Okay, if you're, I think your mic works now, right? Try. What's your y value for next one, Jocelyn? Jocelyn, are you there? Okay, let's see. 2. Okay, how do you get 2? Okay, because you're okay. If you type in, if you sub in -2, you'll get -4 plus, sorry, not -4, -2, right? Plus 4. Yeah, okay, you will get 2, but that 2 is inside the root. Okay, so you should get square root of 2. Okay, so can you find out how big that is? Around, it will be a decimal. Okay, type into your calculator. And Marcus, what about next one?
Isn't it a 1? Oh wait.
Oh,
Oh no. 3. Sorry.
what's that?
Is it 3?
Square root of 3. Okay,
Oh.
it's inside the square root, right? You
Yeah.
put -1 into the function. It'll be -1 plus 4. So the 3 is inside the square root. Okay.
Oh.
Yeah. Okay, and last one, Angela.
I got 2.
2. Yeah. Okay. So square root of 4 will be 2. So the square root 2, square root 3, they're just decimals, right? So it'll be easier to just plot the integer ones, right? So we have -3 and 1 will be up here. 0, 2 will be here. And then anything in between, they're all decimals, right? If you want to find out how big they are, you can type into calculator, right? So something like this. Okay. So like square root of 2, you can see is 1 point something, will be up here. And then square root 3, even higher, right? So maybe like 1.7, 1.8, right? You can type into calculator to find out. Okay, so we get these points. Now let's write down the domain and range. Okay, I'll let you guys try this time. Okay, look at the graph and then write down the domain and range. Okay, please raise your hand if you got the domain and range. Okay, does anyone have questions about how to get domain and range? Okay, because we have two clear here, so if I okay, so clear Zhang. Okay, so can I just call you? How do you want me to call you? Do you have like a different nickname? Clear Zhang, CZ.
Sure.
Okay, yeah, because we got two Claire here. So if I say Claire, there will be the other Claire. If I say Claire CZ, okay, it will be you, okay? All right, so CZ, can you tell us your domain?
X is greater than or equal to -4.
Yeah, okay, great. X greater or equal to -4. It starts from -4 and then keeps on going to the right side, right? So when you talk about domain, you think about left and right, okay? It doesn't go to the left side, it only go to the right. Now, when we talk about range, we need to think about going up and down, okay? So Claire, what's your range?
Anything greater than equal to 0.
Yeah, very good. Okay, so you'll say the y, make sure you write down y greater or equal to 0. So you can see the y value for that point is 0, and then it will start to go up. You see the arrow is going on the same graph, but in your head, you're thinking differently. Okay, for the green, you go up, right? You think about going up. For the red, you think about going to the right side. Okay, so they start with different values. So that point here is at -4, 0, right? Your starting point for the domain and range. Okay, so we are going to speed up a little bit more, okay? The last two functions. Next one is called the rational functions. So rational function also has some restriction, okay? Like radicals, you need to make sure the inside, okay, let's write that down, okay? Inside greater or equal to 0. Okay, for the rational, you have a number, right? You have a fraction, something over something, right? So this is the denominator. What's the restrictions for the denominator? Let me lower your hands first. Okay, does anyone know what's the restriction for denominator? Yeah, Nick?
It can't be 0.
Yep, very good. Okay, anything in the denominator cannot be 0. So just remember these two rules, okay? Those are the two things you will see mostly, okay? Most of the time. Square root inside greater or equal to 0. Fractions, denominator cannot be 0. So let's think about this one, right? What number makes the denominator 0? Let's pick someone else. Oh, I haven't picked yet. Okay, Chris. What makes the denominator equal to 0 for this one?
3.
3, very good, okay? 3, if I put 3 into the x, it will make 3 minus 3, right? So denominator will become 0. So we cannot have that, right? So I'm going to graph around 3 since we cannot input 3. So for your table, you will put 3 in the middle. Okay, and when I put 3 in, you get 8 over 0. This is called undefined. Okay, or you can simply write 0 with a slash through it, right? That just means it's empty. There's no number there. And then we are just gonna graph around 3, okay? So 3 is like the center of your focus, and you want to see what's happening besides 3, okay? So on the left side of 3, you can use 2, 1, and 0, okay? On the other side, you'll use 4, 5, 6. Okay, so for rational number, this is how you can draw the graph. You find out what makes the denominator 0 first, and then graph around it, okay? So please complete the table again and raise your hand. Okay, Callum, do you have the answer for x equal to 0? Callum Chung? Are you there? Oh yeah, your mic doesn't work. Yes. Okay, remember. Okay. Negative. Oh, not okay. Never mind. -4. -4. You put 0 in. Okay, if you put 0 in, okay, look at the screen, right? It will have 8 over 0 minus 3. Okay, so you end up with 8 over -3, not -4. Okay. Can you try again for x equal to 1? Okay, and you can type out your answer. Okay. Philip, do you have answer for x equal to 2?
-8.
-8. Okay, very good. So you have 8 over -2. So yeah, okay, very good. Okay, 8 over negative. And what's 8 over -2? That's -4. Okay, so I think your -4 was for x equal to 1. Okay. All right, and then next couple ones. Okay, Eric, x equal to 4. What do you have?
I have 8 over 1, which is just 8.
8. Okay, and Lily, next one.
4.
What's that?
4.
4. Yeah, very good. Okay, and Yosher, last one.
8 over 3.
Yeah, 8 over 3. Okay, so you can see a number's kind of symmetrical as well, but then one is positive, one is negative. Okay, so we're gonna graph it out. When we graph, we start with the x equal to 3 first. X equal to 3 is right here, right? The red dot there. But then the y value is undefined. That means for any y, it shouldn't have any points. Okay, so to show that, we'll make a dashed line. So it's just saying that at x equal to 3, it's an empty space. Okay, so those dashed line is not points. That dashed line is just showing it's an empty space. You cannot, it's like an invisible wall. Okay, you cannot put any points on that line. Okay, empty. And then anything on the left side, anything on the right side, then you can do the graph. So our first point, let's put 2, -8. It'll be down here, right? 2, -8. 1, -4. Okay, 8 over -3 is about -2 point something, right? So just approximate, right? 0, 2 point something. You can see that it starts to bend, okay? The other side, same thing. 4 is 8, will be up here. 5, 4. 6 will be 2 point something. If you start to make more and more points, you'll see that the numbers, the points will start to get closer and closer to the x-axis, like that. Okay, so you're making curve. Okay, so please complete the graph. All right, raise your hand again when you finish the graph. Okay, so let's see what do you think the domain for this one is? Selena?
X. X is. Wait, I don't know.
You can think of when we say domain is about the x, you're right, okay? So think about what x you can use or what x you cannot use.
You can use all the X.
You can use all any x values.
Oh, not 0.
Why not? We just use 0 in the table, right?
I don't know.
Look at the table. It's the answer is in the table, right? Is there any number I put it in, you don't get an answer out?
3.
Okay, so x cannot be
3.
3. Okay, so when you say the x cannot be 3, at the same time, it's the same meaning as saying x can be anything except 3. Okay, so domain in range is describing what x you can use or what x you cannot use. Okay, as long as you can say that, then it's okay. So you can say x does not equal to 3, right? And x can be anything else. So this part is just saying that x is real number except 3. Okay, so x is real. Real means any numbers. Okay. Real numbers except 3. Okay, if we translate to English. Any questions so far? Right now for the range, if you look at the graph, okay, because it doesn't show that on the table, but the graph, you can see that it extends to the left side, right? Keeps on going to the left, keeps on going to the right. So it looks like it's going everywhere, but then it can never touch the x-axis. So there's another empty space there. That empty space is when y is 0. Okay, so similar to the domain for this one, you'll say y cannot be 0. You can also sort of see it from the table, okay? Think about if X gets really big, right? For example, if I put X equal to 100, then you would have 8 divided by 97, right? Which is pretty small, right? 0 point something. If I make the X even bigger, right? X is 1,000, then it gets even smaller, but there's always a number. There's always a small number, right? So that's why it can never become equal to 0 because of the 8 on the top. Whenever there's a number on the top, it can never become a 0, okay? You can do the same thing here. You can say y cannot be 0, and y can be anything, can be real numbers. Okay, y is a real number except 0. Okay, this is a very special one. Later we have a chapter about graphing rational. Okay, you will learn more, you'll get more practice on this. Okay, so this is just giving you a heads up. Okay, ready for last one here, absolute values. Okay, Philip, do you remember what absolute value does?
Yeah, anything inside becomes positive, right?
Anything, you are 80% correct, has to do with positive, but it's not about the inside. Can anybody else like add to this? What does absolute value do? Yeah, Nick?
I think it's like the negative, like for example, the absolute value of -3 becomes 3.
Okay, yeah, so inside it can be anything, okay? Inside I can put in negative, but then when it comes out, okay, outside, it will be positive. Okay, I put -3 in, it will come out positive. If I put positive in, what does it come out? No, where did it go? Yeah, Daniel, what comes out?
Positive.
Also positive, okay? What about 0? If I put in 0? Yeah, Nick?
Still 0.
Still 0, yeah, okay? So the only thing that it changes is the negative sign, right? It takes away the negative sign. So why do they design absolute value? What's the point? Does anyone know? Why do we need this kind of function? Right, we know square root does something, right? Why design something like this? Is there anything in life that's always positive, right? You can never use negative to represent. Right, you never, for example, if you want to, if you're owning someone money, right, you will use negative, right? You have a mortgage, that's a negative. What kind of things that's always positive? Yeah, Nick?
Like age.
Age, yeah, very
Or
good.
time.
Yeah, or time, very good, okay? So in those cases, we'll use absolute values, okay? So for example, I will say, for example, like someone is 2 years younger than you, right? So for example, one person is 7 years old, the other person is 9 years old, right? So their difference, what's the difference of age? It will be 2 years apart, right? So age, when we talk about years, it's never negative. So you can do 7 take away 9 and then put absolute value around it. 7 take away 9 is -2, right? But since we're talking about years, we need to make it positive. Okay, so when they ask, please find the age difference between the two people, then you always put absolute value around it. Okay, so that makes things positive. Another scenario you use absolute value is like distance. okay? Because you don't care about positive, negative, okay? From one place to the other, the distance is always positive. Just a few example, right? Because maybe you wonder why they designed this, right? So now you understand what it means. We'll need to pick some points. So like we said here, right? Because the inside can be anything, there's no restriction. So right away, we can say the domain is real number. Okay, this one is the easiest one. Now, because we can use any number, but I don't want to just pick like 1,000 to put inside. Okay, so I'm gonna pick something that makes the inside 0. Because 0 is kind of like in between positive and negative sign, right? So it's like the center of the whole graph, whole function. So what number makes the inside 0? Jenny?
For question D, right?
Yep.
-3.
Yep, -3. So we'll pick -3 in the middle, okay? So it's different from rational, okay? For rational function, we also use the number that makes the denominator 0. But for that place, you cannot have an output. But for absolute value, you could get an answer out, okay? So if I put -3 in, -3 plus 3 is 0, right? And 0 absolute value is still 0. Okay, so this time it's not undefined. And then we just graph around it, okay? -2, -1 on the right side, right? And then you have the left side, -4, -5. Okay, so please complete the table and raise your hand. Okay, Marcus, what's your answer for -1?
Isn't it just 2?
Yeah, very good. And Waylon, next one.
Is it 1?
Yeah, okay. And then for x equal to -4, Susan?
One.
Yeah, very good. Okay, x equal to -5, Angela?
2.
Yeah, very good. Okay, so everything that comes out has to be positive. Okay, so we have -1, 2. -1, 2 is up here. -2, 1, -2, 1, -3, 0, -4, 1, -5, 2. So looks like a V shape, right? Okay, so what about the range? Okay, we have the domain. Domain is any number we can put it in, right? Could be decimal, could be negative, could be fraction, right? Any number you like. What do you think the range is? Look at the graph. What's the range, Evan?
Anything greater than 0?
Greater
no,
than
no.
0? Can it touch 0?
It's not. Yeah. No,
Yeah?
it can't. Yeah, it does. It does.
So what do you say? The range should be, how do we write it?
I'm not quite sure what the range.
Yeah, greater or equal to 0, right? So you can see the graph, range is going up or down, right? So this one, the graph, it starts from 0 and goes up, doesn't have a stopping, right? Either left side or right side, and then goes down, the lowest is at 0. Okay, so that's the 4 functions. These 4 functions are very important because on the next topic, transformation, we'll be using these ones as well. Okay, so that's why I spend a lot of time. And then you can remember these, what they look like. Okay, we'll have a break for 10 minutes. Okay, so right now it's 10:45, so we'll come back at 10:55. Okay.
Jason,
Yeah.
did you get the thing from my mom that we have to leave at 11?
You are.
I have to leave at 11.
Oh, okay. Yeah. Okay. Where are you going?
The soccer game.
Okay. Yeah. No
I
problem.
watched the video though for the
Okay.
second half.
Yeah. Yeah. Second part very important. Okay, for your homework.
Yeah.
Okay. Yeah.